Try it again. Understanding of the mean value theorem here is, mean value theorem cannot be used, which means we cannot guarantee a value of C on the given interval. We cannot guarantee a value of C on the given interval. Okay. Function f of x equals absolute value of x minus 1 is equal to 0 at x equals 1 and negative 1. Does the mean value theorem apply to f prime of c equals 0 for some number c between x equals negative 1 and x equals 1? What are your thoughts? So we still need to check continuous and differentiable. Is it continuous? You can plug any number in there that you want to. The graph is one continuous what shape? V. So it's continuous. What about differentiable? That's a no, because there would be a hard point, sharp point at x equals what? 0. And what interval were they trying to ask us to work with? Negative 1 to 1 again. Now, if they gave us a different interval, it might be different. But since this is the interval they gave us, mean value theorem does not apply. Okay. Oh, I almost forgot about, they gave us one little, like, I don't know, do I want to say blurb about Rolle's theorem here. And it says, if f is continuous, so there's 3 criteria here. If f is continuous between a and b, if f of a and f of b equals 0, and if f is differentiable on the interval a to b, then some number c exists between a and b such that f prime of c equals 0. Okay? So, I'll try and sketch a little something or other for us here. There's my x-axis. We have an a and a b value, right? So let's see, f is continuous. So from a to b, that just means my graph is continuous, right? Before I draw this, what do you know about f of a equals f of b equals 0? Okay, so the y values are 0 and it starts and ends on those. So both of those points are on the x-axis. So f of a is right here. F of b is right here. What's the graph do between there? We don't know, right? But it's got to go up and come back down, or it's got to go down and come back up, or it's got to do a little bit of both, right? But it's some curve. I don't know. That's my picked curve. Pick whatever curve you want. It's differentiable on A to B. So that just means I didn't make any sharp points, basically, right? So continuous. F of A and F of B are zeros. It's differentiable. Then what's it say? Some number C exists between A and B such that, what does F prime of C equals 0 mean? Okay. I wasn't thinking that way, but yeah, okay. So we can talk about there's a min or a max when the derivative equals 0. What's another word for derivative also? Slope. What's a slope of 0 mean? A horizontal tangent line, right? So in this case, can you see at the top here? Would there be a horizontal tangent line? Or as Nathan called it, a min or a max? There's a max. A horizontal tangent line of 0. Because when we talk about the derivative equaling 0, just totally reverse those letters. Remember, derivative is also slope. So we're talking about the derivative equals 0 or the slope equaling 0. So some point exists where there's a tangent that is a slope of 0, or there's a min or a max. And keep in mind, I made mine a max. I could have just easily made it a min. And nothing says there could be more than one. I just picked one. Okay. Let's talk about our speed trap. Suppose two stations are 60 miles apart, and we drive between the two in exactly 1 hour. Then the average speed is given here. Okay, so two stations 60 miles apart, we drive between the two in exactly an hour. So the average speed is the idea of your location at 1 hour minus your location at 0 hours, right? So how far did you drive? Which was 60 miles over 1 minus 0. 60 miles divided by 1 hour is 60 miles per hour. So that is your average speed. Is that saying you went exactly 60 miles per hour the whole time? No. It averaged out to be that. You went slower, you went faster, some combination thereof. So, notice, this is equivalent to the mean value theorem. Okay? The mean value theorem would say f prime of c is equal to f of 1 minus f of 0 over 1 minus 0 is equal to 60. 60 miles per hour at some instance, c, in the interval from 0 to 1. So, if the posted speed limit was 55 miles per hour, then at some point, the driver was going in excess of the speed limit, going 60 miles per hour. And of course, then it says this can be useful in courtrooms. Okay, so at some point, you had to have been going 60 there. I'm not saying you were the whole time. And in all honesty, if you were going below 60 at some point, then you had to be going above 60 at some point for it to all average out. Okay, so let's look at the example and see how we can apply this. The speed limit on a highway is 65 miles per hour. At 6 p.m., a police officer sees a truck going by at 60 miles per hour. They were being good, even going 5 under the speed limit. The officer radios another police officer 70 miles down the highway who sees the same truck go by at 7 p.m. at 60 miles per hour. Find the average speed of the truck between 6 p.m. and 7 p.m. Okay, what do you know?
The f of 1 minus f of 0 over 1 minus 0.
Okay. Which, when we say f of 1 minus f of 0, that's really the distance at time 0, the distance an hour later, right? So you could also think of it as the distance, if you want. And what is that distance? How far did they travel? 70 miles. Now, divided by 1 minus, it said 1 minus 0 up above, which, how much time passed, basically? How much time passed was 1 hour. So what's 70 miles divided by 1 hour? 70 miles per hour. Okay, so that's the average speed of the truck between 6 and 7. The truck driver is ticketed for speeding, but he argues he was never clocked to 60 miles per hour. The truck driver is convicted by a judge who points out that he must have been traveling 70 miles per hour at least once. Is the judge right? And actually, this really should say he was never clocked above 60 miles per hour, if you want it to make sense there. So, do you deserve the ticket?
Maybe the wind was just pushing him forward a little bit.
But you're still speeding.
But that's still registering the speed.
Maybe not. Never saw him.
Is your backup plan to become a lawyer?
Maybe he warped space-time and just happened to get there. Yeah, but it's not worth a speeding ticket.
Okay.
He crossed the time
You
zone.
can't give a speeding ticket for time travel.
He crossed the time zone.
Yeah, there you go. He crossed through a different time zone.
He was going from Indianapolis to St. Louis.
The judge is wrong.
So he stopped at the Flying
He's
J
just-
for lunch,
Does it say what?
and that's why it took him
Does it say
2
if it's
hours.
the same day or not?
Could be 7 p.m. the next day.
Luckily, they would have that information in the courtroom.
Well, we don't have that information in our courtroom.
So is the judge right?
No.
Okay, you guys are obviously on the side of the truck driver.
It's very wrong.
That's fine.
We cannot confirm more about it.
I cannot right answer this question. I'm sorry.
Okay. I'm going to say,
Look, maybe not.
if he never went over 65 miles per hour, then, I say 65 because that was the speed limit, then he could not have traveled more than 65 miles in the hour.
Here's another thing. What if the second police officer wasn't quite 70 miles? Did they measure it perfectly? Because he could say, yeah, it was 70 miles away.
I'm guessing if you really want to argue that, you'd go check the locations.
I
But
think I need to.
I'm going to say, by mean value theorem, the driver's speed reached 70 miles per hour at least once.
A little evidence.
I feel like you need to be a lawyer.
I know.
Just a lawyer in the classroom then, huh?
Thanks.
We were all lawyers in Club's class, remember?
I won my case, alright?
Well,
In whose class?
in Mr. Club's 9th grade English.
That was fun.
So this is only his third year gone?
Yeah.
Oh wait, did Miss Mooney replace him?
Yeah.
Okay, so that would make sense then, 'cause this is her third year here. Or excuse me, Mrs. Miller.